Welcome to Mastering Solutions. In this MCAT style problem, they want us to find what the tree's speed of growth is in feet per year from T1 to T3. And so while we're doing this, what we're going to do is we're going to find what the change in the feet is, and they say it's the change per year. So obviously feet per year. And anytime we have change of anything, it's always final minus initial. So whenever we do that, it's going to be feet final minus whatever the feet in growth is initial. And then all of that will be divided by the year final minus the year initial. And so all the information is given to us, and it's in the units we want. We want feet, which the Y is, and the T is in years. So if we plug this in, the feet final is in year 3, it grows to 30 feet tall. So we have 30 feet minus initially it is 12 feet tall at year 1. So 12 feet. And then they say 1 to 3, of course. So year 3 is the final minus year 1 is the initial. And when we do that, we get 18 feet per 2 years. So 18 divided by 2, of course, is 9 feet per year. So when we come to the question right here, looking at our answers, we have 12, 9, 6, and 8. So obviously the answer is B, 9 feet per year. So now I'm going to do all 3 questions in the same video. So let's get rid of this and we'll do the second question. So now for the second question, they want us to take whatever the speed we got for the first one, which we found to be 9 feet per year, and then convert that into meters per second. So let's write down the 9 feet per year. So I'm going to do it down here so we have plenty of room. We have 9 feet for every 1 year. And they want that in meters per second. So let's first do the feet and put that into meters. You can do the years first if you want. I'm just going to do the feet first. It doesn't matter though. So in 1 foot, there are of course 12 inches. The feet will cancel. Now we know in 1 inch, there is 2.54 centimeters. Now the inches cancel. And in 1 meter, there are 100 centimeters. So the centimeters cancel, and now we're in meters, which we want, and we want to change the year to seconds. So in 1 year, there are 365.25 days. And then in 1 day, there is 24 hours. And in 1 hour, there is 3,600 seconds. So now, of course, the year will cancel, the days cancel, hours will cancel, and we're left in seconds. So meters on top, seconds on bottom. So now let's go through and calculate this out. So if we have 9 and then multiplied by 12 to put us into inches, and then multiplied by 2.54 to put us into centimeters, divided by 100, now we're in meters, 1,000, 100. And then we're going to divide that by 365.25 days and divide by 24. And lastly, divide by 3,600 to put us into seconds. So that gives us 1, 2, 3, 4, 5, 6, 7 zeros. And so we can put that into scientific notation by moving the decimal place. So it'll be 1, 2, 3, 4, 5, 6, 7, 8. So 8.7 times 10 to the negative 8 meters per second. Or we can go up here to mode and let the calculator do it for us. Let's get out of here and then press enter, and we have 8.7 times 10 to the negative 8, just like we said. So we can round that, and we'll round that to 9. So when we look at our answers, we have 9 times 10 to the negative 8 meters per second. Perfect. So the first one is the answer that we got. And that is the speed of the growth from 9 feet per year in meters per second. So now let's move on to the last one and get rid of this and pull up the last question. All right, and so for the last question, they say that at the end of the 3rd year, they tie a rope from the top of the tree to steady it, and the rope is staked at the ground 15 feet away from the tree. What angle does the rope make with the ground? So let me redraw the tree just so we have some more room. Okay, so we have our picture of our tree at the end of year 3, And they say that they tie a rope from the top of the tree down to the ground. And they tell us that this distance right here, that distance right there is 15 feet. And they want to know what angle the rope makes with the ground right here. We know that the end of the third year, the tree was 30 feet tall, so we can put that right here. So that's 30 feet. So now we have our triangle. The opposite is 30, the adjacent, we have that, so we can use tangent to solve for the angle that it makes with the ground. So we'll use tangent from the SOHCAHTOA, and the TOA stands for tangent of the angle is equal to opposite over the adjacent. We're looking for the angle right here though, so if we move tangent over to the other side, we have theta is equal to tangent inverse times opposite over adjacent. And then when we plug in our numbers here, we get inverse tangent times the opposite is 30 feet divided by the adjacent is 15 feet. And so theta, let's plug this in. Inverse tangent of 30 divided by 15. So I was in scientific notation still from the previous part of the question, so I change it back to normal, and that gives us 63.43. So rounding down should be 63 degrees. And then if we come up to our answer here, again, A, first one. So the answer is it makes an angle of 63 degrees with the ground.